Welcome back everyone, Patrick here, moving on to another question dealing with quadratics. So what we have to do in this video is find the point or points of intersection between the circle x squared plus y squared is equal to 25 and then these quadratics right here. So there's going to be three different cases. Now, before getting into these specific quadratics and this specific circle, just generally I want to talk about or show you visually what are the different cases that can happen in terms of a quadratic and a circle intersecting. So one case is you can have a quadratic that is going to intersect a circle at 2 points right here. You could have another case where you have a circle, and then you could have maybe a quadratic that's going to intersect the circle at 4 points. Then you could also have another case where you have a circle, and then perhaps you have a quadratic that intersects the circle at no points. And then this quadratic can also be flipped over, right? It could be like this one, it could be opening down, etc., etc. It doesn't matter which way the quadratic is opening. So different kinds of cases you can run into, and as you guessed it, with these three different quadratics, all of them are going to be different cases in relation to this specific circle x squared plus y squared is equal to 25. Now, lots of times you can make an initial diagram and see what you're going to expect your result to be. But that's not always going to work out, but I think for the first one it will. So x squared plus y squared equals 25. So we could tell, remember the radius, an equation of a circle is equal to x squared plus y squared equals r squared. So if we square root 25, that would give us 5. So we have a circle that's centered at the origin, and it also has a radius of 5. So this point is going to be 5 and 0. This point here is going to be 0 and 5. This point here is going to be negative 5 and 0. Then this point here is going to be 0 and negative 5. Okay, when I'm doing this question, I'm assuming that you are fairly comfortable with circles. We've covered them in previous units. I'm not going to focus too much on how to draw it. This is more so a video in terms of dealing with the quadratic formula and dealing with quadratics just in general. So if I take x squared minus 4, notice that here it's in that ax squared plus c format. We always know the vertex is going to be at 0 and c. So notice here the c value is negative 4. Where's negative 4? Well, negative 4 is like right here. So right here is going to be the vertex of this quadratic, and it's going to open up because we have a positive 1 here. And so if this opens up, well, we could tell that this quadratic is going to intersect at those 2 points. Again, with a drawing, it's not always going to be super obvious. So like for x squared minus 16, x squared minus 49, the vertex is going to be below the circle. And sometimes it's tough to tell, okay, is it going to go through the circle or is it not even going to touch the circle? But sometimes with this kind of quadratic that's within the circle, where the vertex is within the circle, you could tell it's going to intersect at 2 points. And so it gives us something to expect, a certain way to check our answers. So how do we find the points of intersection? Well, it's basically, we got two equations. Let's write them over here. And we have two unknowns, right? X and Y. And so I'm going to do substitution. And I'm going to isolate for variables here in the quadratic and then plug them into the circle. Now there's different ways to do it. Notice here the y variable is isolated. So if you wanted to, you could take x squared minus 4, plug it in for this y. But the problem is here is that when you expand this, x squared minus 4 times x squared minus 4, you're going to be dealing with a large power here to the power of 4. And so I wouldn't recommend going about it that way because the algebra is going to be fairly intense. What you can do here, if you notice, we have an x squared expression here, and we also have an x squared expression here. So what I'm going to do is I'm actually going to isolate for this x squared. I'm going to bring the negative 4 over. And then I could plug in this y plus 4 for that x squared. And then notice the exponents when we do that. So if I take that and plug it in here, we would end up with y plus 4 plus y squared equals 25. And notice now here, the exponents that we're dealing with are a lot smaller, right? So that's personally what I would do. I would isolate for the x squared and then plug it in for that entire x squared right there, this expression, whatever it's going to be. Okay, and so from here, this is just a quadratic equation. If we bring the 25 over, 4 minus 25 would give us negative 21, and then that's going to equal 0 like that. And so from here, this is just a quadratic equation. We can plug this in to the quadratic formula. Okay, this is not going to factor over here. The a value is 1, the b value is also 1, and then the c value is negative 21. And so plugging this into the quadratic formula, we'll have negative b, which is negative 1, plus or minus b squared, so it's 1 squared minus 4 times the a value of 1 times the c value of negative 21. And then that's going to be all over 2 times that a value of 1 right there. And so from here, we can simplify this. We'll have negative 1 plus or minus, this would be what? Negative 4 times negative 21 is 84 plus this 1 squared, which is just plus 1. So we'd end up with 85 under the square root. This is going to be all over 2. And when you do that algebra, negative 1 plus root 85 over 2, you'd end up with 4.11. Negative 1 minus root 85 over 2, you'd end up with negative 5.11. And remember, these are the y values that we are solving for. So I'm going to write that, let's keep track of it here. So we have one solution, y equals 4.11. Then we have another solution, y equals negative 5.11. Now, one thing you might be asking yourself at this point, this is important to know. Okay, if we look at our diagram, these points of intersection here, right? We're getting x and y. We're getting here x and y. Now, it makes sense that we would get a positive y value right here, right? Because notice that these points, according to this diagram, they are above the x-axis, meaning they have a positive y value. So it makes sense that we get a positive y value. But then notice here we got a negative y value as well. Okay, and then when we look at this, notice that this negative y value doesn't make sense because there's no points of intersection between the quadratic and the circle that have a negative y value in the diagram. And we're going to see how this here is an invalid solution when we take this, plug it back into the original, one of the two original equations, and then solve for the corresponding x value. You're going to see that this actually doesn't work out. So sometimes when you're getting these solutions initially, whether for x or y, and it's not making sense according to the diagram, make sure you finish the question all the way, and you'll see then that the final points that you get should make sense with what you're working with. And so taking these and plugging them back in, we could plug it into either equation that we want, these two y values here. So before discounting the negative 5.11, let's see if it works out if we plug it in. Well, notice that if we take this y value, negative 5.11, let's say we plug it in over here into this equation, into the quadratic, plugging in negative 5.11 here, well, notice, bring the negative 4 over, negative 4, or negative 5.11 plus 4 would give us negative 1.11. We'll have x squared. Notice we can't square root a negative. And so we would get no corresponding x values for this negative y value. Okay, it's not going to work out. Or if we try to take it and plug it into the other equation, so if we took that negative 5.11, plugged it in here for this y, and we're solving for this x, notice negative 5.11 squared, I'm not sure exactly what it's going to be, but it's going to be over 25. So we'll have x squared plus some kind of number that's greater than 25. Let's say it's like 25. I'm not sure what it's going to be, but let's say it's like 25.3. It's going to be some kind of number greater than 25. Well, when we bring that number that's greater than 25 over, we'll have 25 minus that number, which is going to give us a negative value over here. We'll have x squared equals a negative value, and then to isolate for the x, it's not going to be possible because we can't square root a negative value. And so that's the step, whether you do it with this equation. I recommend doing it with this one because I feel like there's less algebra. Or you do it with this one, you'll see that this y value, negative 5.11, it doesn't give us any corresponding x values that are valid. You're going to get to a point where you're going to be square rooting a negative value with whichever one you plug it in. And then you're going to see for x squared minus 16, just as a spoiler alert, there's going to be 4 points of intersection for this quadratic. And you're going to see we're going to get to this point and we're going to be able to solve for other x values that have a negative y value. Okay, but in this case, we can't do so, right? So this is not going to work. And that's how we could tell algebraically. Now, what about the 4.11? Well, we'll have, if we plug it into this one, again, it doesn't matter which one you plug it in, you'll still get the same corresponding x values. You could take the 4.11, plug it in for this y, or you could plug it in for that y, doesn't matter. I'm going to plug it in for this one over here. Bring the negative 4 over, we would end up with 8.11 is equal to x squared, and then we would square root both sides. And notice that when we do that, we'd end up with x equaling the square root of 8.11 is approximately 2.85. Now remember, a square root, it could be plus or minus. And that makes sense that we're getting two x values because there's 2 points here that we're looking at. So let me actually erase some of this just so you're not getting confused with what's going on. So we're solving for these points. Notice that one of the points is going to be positive 2.85 x value and that y value of 4.11. And then the other point is going to be negative 2.85 with that same y value of 4.11. And that makes sense according to the diagram. Notice that both of these points, they're on the same height, meaning they have the same y value. Both of them have a y value of 4.11. It also makes sense that that y value of 4.11 is less than this y value of 5, because that's like the max point of the circle. So obviously these y values should be less than 5. It makes sense that we got 4.11. That's actually another thing I forgot to mention. When we got these values, notice that this negative 5.11, it's actually outside of the circle because this is a negative 5 y value. So negative 5.11 is somewhere down here. Wouldn't make sense to get points over there, right? Those points wouldn't be intersecting that circle. That's another thing I forgot to mention. 4.11 versus 4.11 is below that y value 5. So this point is negative 2.85, 4.11, and then this, or sorry, that's positive 2.85 and 4.11, and then this point here is negative 2.85 and 4.11, like that. And also, if you look at the x values, notice this x value 2.85, less than this x value of 5, right? It's to the left of this x value 5. This is the rightmost point, so that's the highest x value on the positive side. This here is the lowest x value on the negative side, and negative 2.85 is to the right of this point. So it all graphically makes sense as well, not just algebraically, but you could take these points, look at the graph, and see if it makes sense that way. All right, so those are the 2 points of intersection for part A. Now, what about part B? And what's going to happen in part B, so we're going to have that same circle like this, right? These points are going to be at 5. The intercepts, though x and y intercepts, are going to be at 5. But notice x squared minus 16, it's actually below here. The vertex is below. Could have maybe made this a little bit bigger. It's all good though. So here, that's the vertex. One thing I want to mention here about this quadratic, notice that what are the x-intercepts of this quadratic? Well, if we plug in y, 0 for y. Again, what I'm doing right here, right now, it's not totally necessary. I'm just trying to show you visually what is happening. But if you want to go straight into not even making a diagram, just go straight into finding the points of intersection algebraically, you can do that as well. We're going to do that as well. I'm just trying to sort of give you a preliminary visual of what's happening so you understand a little bit better. So right now I'm just going into a little bit more detail in terms of graphing this quadratic. Sometimes you're not going to get a smooth quadratic like this. This is obvious difference of squares that we could factor easily. Sometimes you'll be working with quadratics where it's tough to tell how it's going to look like to make that preliminary diagram. And then just to save time, perhaps on a test, then it might be worth it to just go straight into the algebra. But these are fairly easy quadratics to work with, and so I'm just going to make some visuals so you could see. Now, x equals 4, x equals negative 4. Notice that this here is at 5 and 0, and this is at negative 5 and 0. So notice that 4 and 0, negative 4 and 0, those are going to be within right there, like that. And those are going to be the x-intercepts of the quadratic. So it has a vertex at 0, negative 16, and it's going through those intercepts like that. Okay, so it's easy to tell that this quadratic and this circle, how many points of intersection are there going to be? 4 in this case. 2 here and 2 right there. Don't get confused with these points. Maybe I can, just so you're not getting confused here with too many points drawn on the graphs, I'll get rid of those. And just knowing that this here is at negative 4, 4, this is at negative 5 and 5, right? So these 4 points, let me even take out the vertex here. Those are going to be the points of intersection right there. Okay, and so let's see if we actually get that. So again, the two equations, again, if you didn't want to make a visual and you just wanted to go straight into solving the points of intersection, you could ignore that part, ignore what we did before, just go straight into isolating for the x, bring the negative 16 over, then I'm going to take this y plus 16, plug it in for that entire x squared. So we'd end up with y plus 16 plus y squared equals 25, and then bring the 25 over, we'd have y squared plus y. 16 minus 25 will give us what? Minus 9. That's going to equal 0. Then this is not going to factor. We got to put it in the quadratic formula. A value is 1, B value is 1, C value in this case is negative 9. So we'd end up with 1 squared minus 4 times 1 times negative 9 all over 2 times 1. So we'd have negative 1 plus or minus, this would be 36 plus 1, this would be 37. That's going to be all over 2. And in this case, notice that we end up with 2 y values. So those are the 2 y values. Let me write these down. And notice, according to our diagram, these y values actually make sense. Both of them make sense. We have a positive y value, which is right here for these 2 points. And then notice that this positive y value 2.54, it's below this y value of 5. And then notice that negative 3.54, that would be the y value for these points. And notice that this y value, it's above. This should be the circle should be a little bit more down, and then this minimum point of the circle should be at negative 5, right? Versus before, we got a negative y value below the circle, which wouldn't make sense because then the quadratic wouldn't be able to intersect the circle at that kind of y value. So notice that both of these y values are contained within the circle, right? So it's making sense according to the diagram so far. And so from here, what we want to do is we want to find the corresponding x values for both of these. And so we could plug in both of these y values into either equation, doesn't matter. I'm going to plug it into this equation for both and just work with that. But again, it doesn't matter. So I'm going to plug in negative 3.54 here. We're going to solve for the corresponding x values. I'll plug in 2.54 here, solve for the corresponding x values. So over here, bring the negative 16 over, it becomes positive 16. And so this would give us what? 12.46, right? 16 minus 3.54 is 12.46. That's going to be x squared. Bring this over, we'll have 18.54. That's going to be x squared. And then we just square root both of those sides to get the x by itself. And when you do that algebra, you'd end up with these two x values, and then you'd end up with these two x values. So notice that both of these y values, they both have two x values, both of them. So in total, there's actually 4 points, right? So with these two x values, we have positive 3.53, negative 3.53, for the same y value of negative 3.54 that we plugged in over here. So those are two sets of points. And then these x values of 4.3 and then negative 4.3, both of them are for the y value of 2.54 that we plugged in. Right? So notice in this case there were no negatives under the square root we had to worry about. We had a positive, we had a positive. Hence why we got 4 points of intersection. Okay, so for the negative y value, that's both of these. So this point here would have a negative x value, so it would be negative 3.53, negative 3.54. And this point would be positive 3.53, negative 3.54 for the y value, right? Both of these have the same y value. This one over here, we'd have a negative x value, negative 4.3, and then we'd have a positive y value, 2.54, and then this point would be positive 4.3, and then that same y value of positive 2.54. Right, so 4 points of intersection, and again, according to the diagram that we made initially, where we graphed the circle, and then we took this quadratic, got some characteristics of it in terms of the vertex being at negative 16, in terms of the intercepts being at plus and minus 4, then when we connected everything, it made sense that we should expect 4 points of intersection. And we did get it algebraically. There was no issues with that. Okay, and then finally, this last case, as you guessed it, well, the first case had 2 points of intersection. The second case had 4 points of intersection. Well, what is this case going to have? Probably 0 points of intersection. But let's again go into a little bit more detail now. X squared minus 49, the vertex is at 0, negative 49. So notice that that's going to be way down like over here, 0 and negative 49. And then notice again, this is a smooth quadratic where we can get the x-intercepts very easily by just factoring that as a difference of squares, x minus 7, x plus 7, so the two x-intercepts are x equals 7, x equals negative 7. Now, where does that fall in the graph? Well, if these x-intercepts are at negative 5 and positive 5, right, this circle, same circle we've been dealing with, well, notice negative 7 is going to be here, positive 7 is going to be out here. So when we connect the vertex to those two intercepts, notice according to the diagram, it doesn't seem like this quadratic and this circle are going to intersect. Again, we're going to show it algebraically, but a lot of times if you're working with a nice quadratic where it's easy to quickly graph it, again, that's not always going to happen. But if so, I think it does help to make a diagram initially just so you could see what the expectations are going to be. So let's see what happens here algebraically. We should get no points of intersection in this case, right? So let's see what happens. So we're going to follow the exact same procedure where I'm going to isolate for this x squared, bring the negative 49 over, and then I'm going to plug in this for this x squared. So we'd have y plus 49 plus y squared is equal to 25. Bring the 25 over. We'd have y squared plus y. 49 minus 25 would give us what? 24? Positive 24? That's going to equal 0. So throwing these into the quadratic formula, we'd have negative b, so negative 1 plus or minus b squared, which is like 1 squared, minus 4 times the a value of 1 times the c value of positive 24, all over 2 times that a value of 1. And so from here, hopefully you could tell what's going to happen we're going to get a negative under the square root because we'd have -1 plus or minus, we'd end up with 1 squared, which is 1, minus -4 times 1 times 24 would give us -96. And then that's going to be all over 2. Well, notice we can square root a -95 right here. And so it breaks right there. In the first example, notice that we got a negative square root further down in the process of solving, where it was only one of the y values that made the expression under the square root negative. Well, notice that in this case, we can't even get any y values initially because this negative under the square root, it's happening earlier in the process. And so at this point, there's literally nowhere for us to go. There's no y values that we could test. At least in part A, we had a positive y value, a negative y value, then we could test both of them. One of them didn't work out, right? Same thing for part B. We got 2 y values, and both of them worked out, gave us corresponding x values. Well, in this case, can't even get any y values initially, right? So it breaks earlier in the process. And so from here, nowhere for us to go. So we conclude that there are no points of intersection. So we showed it algebraically. Right here, it broke. And then also graphically, it makes sense that this quadratic and this circle have no points of intersection.